Hey everybody, Shawn here with the Automation Blog and School, and in this episode of the Automation Podcast, I sit down with Adam Davis from Rockwell Automation to learn all about their new PowerFlex 755 TS drives. Adam, thank you for coming on the Automation Podcast to tell us all about what's new with PowerFlex drives. Before you jump into the content, can you tell our audience a little bit about your role at Rockwell Automation?
Yeah, absolutely, Shawn. And thanks for the opportunity to share what we have going on with PowerFlex Drives technology. So I'm Adam Davis. I'm a global product manager in our low voltage drives business at Rockwell Automation. Been with the company over 15 years. Over half of that has been spent in the drives world. So really excited to launch this new platform of drives technology and keep forcing ourselves forward, right, as an innovator and leader in the drives VFD space.
Awesome. I'm looking forward to it. It's been a while since I've actually sat down and looked at what's new from Rockwell on the drive side. So really looking forward to it.
Yeah, absolutely. And, Shawn, we're going to spend a little bit of time talking about some of the new products that are coming to market. Now, I'll touch on the entire portfolio as a whole. But I wanted to start there just to get a baseline. And then we'll spend a fair amount of time talking about what we call our total force technology, which is our next generation of controls technology that we're using, the PowerFlex 520, or excuse me, the 750 series drives. Specifically getting after some of the new functionality, new features that really make it a lot easier for our SIs, our OEMs, as well as our end users to go and interact with the drives and make sure that they're operating at optimal capability in the highest performance possible. So to get grounded on that, I do want to talk about our latest and greatest development and soon to be released PowerFlex 755 TS drive. So again, this is our next generation controls technology, but the idea here and the concept for us is to leverage the existing 750 series. So this would be our 753 as well as 755 drives in that current existing footprint, but then doing the internal change, right? Next generation drive solution that is a bolt-in replacement for the old drives. So the 753, 755, as well as the 755 TS are going to share the same footprint. So really important takeaway there, especially for our integrator partners or our OEMs. The benefit here is you're not changing your technology, you're not changing your designs in your machines. Instead, you're just utilizing that new technology with a bolt-in replacement for that existing drive. Nice. So it is a next generation drive, which is critically important. It's a single drive that's going to be able to run all of your applications, which is really, really important. The idea here with PowerFlex technology is it's made to be flexible. It's made to be used in all of those applications, from simple fan and pump applications, so if you will, a starter replacement, all the way to your highly integrated, coordinated drive systems, the most complex systems that we do, in the paper as well as the metals world. On top of that, we've always had an eye for safety as well as security in our products, and so we made some enhancements in these drives, especially around the SIP security protocols that we utilize, as well as safety, making sure that safety is at the forefront of everything we do inside of Rockwell Automation, and making sure that any of those new technologies that we've developed, things like advanced safety over Ethernet, come along for the ride as well. Of course, this is all enabled using our Premier integration experience, and that's really the integration into the Studio 5000 environment to make it very easy for folks to go in, configure the drives, and then use it inside their automation platform. So with that being said, that's kind of the baseline, but the real wow effect is in this total force technology. And I'm just going to step back for a second here, Shawn, because total force technology is actually, it's a bit of a play on words for us, based on the evolution of our drives platforms. And for those listeners that are familiar with the 1336, specifically the 1336 force drive, you're probably familiar with that word force. In fact, it stands for field-oriented control. And so what we've done here is we've taken the foundation of understanding of field-oriented control, force technology, and we've made some major enhancements, especially around high-performance motor control. And that's the reason we call it total force control. So real simply put, total force control is an evolution of that force platform that we developed all the way back in the 1336 days. And really, if we talk about the key benefits of the total force technology, it's going to be in 3 areas. The first one being high performance control, the second one around real-time operational intelligence, and then the last one around automated commissioning and optimization using our adaptive control technology. And the whole purpose of all 3 of these technologies that are underneath the whole hood of this new PowerFlex 755T is that we're going to be able to reduce the staff training. We're going to be able to reduce that dependency on, that aging workforce, those folks that are 20, 30, 40 years of drives experience. Those folks are, at the point of leaving the job market, leaving those industries. And so what we're trying to do is essentially create a solution to bridge that gap in controls capability and understanding of drives and VFD technology, utilizing these 3 core tenets of the total force technology. So just real quick, a couple of specifics around the TS drive. Since this is the latest drive to be released as part of our total force platform, I did want to just give a real quick shout out to this technology and some of the capabilities here. So first off, power range. This is a 1 to 400 horsepower drive. It is a wall-mounted drive. You can see a picture here in the center. This is what the drive looks like. Of course, it scales as we get into the higher horsepowers. It does have a 0 to 60 degrees C operating temperature. This is extended from our 755 drives. So again, we're going to talk a lot about the enhancements in terms of performance between the 755 and the new 755 TS platform. Temperature being one of those big winners here. Before we were able to operate at 0 to 50 degrees C with the PowerFlex 755. Now we're able to enhance that up to 60 degrees C for operating temperature with the 755 TS control. There is some derate from a power perspective in order to hit that 60 degrees C operating temperature, but certainly provides a little bit more flexibility, especially for those folks that are working in high ambient temperatures or conditions, excuse me. Same capability and support for the 5 option slots that you had in the 755. Same I/O cards, safety, communications, feedback. All of those cards are now compatible with the 755 TS. So the same cards that you're using today, we're making that really simple as you migrate forward to the 755 TS, being able to support all of those cards. From an environmental protection perspective, so ingress ratings, we do have the IP20 as standard, as well as an IP54, an enclosed solution for those folks that are looking for the standalone drives. We also have a flange solution. So great way is you're starting to package these into your own enclosures. The flange helps to dissipate that excess heat, reject it into the air outside the cabinet, as opposed to trying to put it on the inside of the cabinet and therefore have to add some forced air cooling or other devices, air conditioners, for example, to manage the heat. So key takeaway here, identical mechanical and electrical considerations, exact same terminal points, right, for all of your power landings as the existing 755 product. So simply making it a lot easier for those customers that are familiar with this drive.
I want to just
yeah, go ahead.
I just wanted to throw out for the audio audience. This looks very similar to a standard PowerFlex 755. Slight differences, but it does look similar. One of the things I noticed is it almost has a look, almost like the new controllers. The front bezel, the shaping of that. I don't know if you guys have an internal term for that, where it comes, it's square, but at the bottom it comes in a little bit. But I also wanted to mention too that just like with the controllers, the XT model is a darker gray. So for anybody listening, you can picture 2 Rockwell Allen Bradley drives side by side. The XT model, like the controllers would be, is a darker color, and that's how you can tell it's the XT. And it does have the XT logo on the bottom.
Yep, certainly, Shawn. And while we're on the subject of XT, this is a great time to bring up what XT means for these drives. So obviously carrying on the same branding and color differentiation using that XT technology as we have in our controllers. For our drives, XT technology is around our enhanced corrosion or corrosive gas environment protection. This is really around extending the longevity of our drives in those corrosive environments. So as we get into applications in industry where we have another number of sulfides, for instance, in the air, those have an impact on the life expectancy of electronic components as a result of various dendrite growths that can occur on the electrical components. The XT technology, specifically for 755 TS, is around ensuring that we put in protections, internal protections, to support a longer life, right, extended longevity in those environments. So what we've done with our XT technology, and again, brand new technology that we're releasing with the TS platform, is now provide a solution to our customers that drives that longevity, that life expectancy, of 12 to 15 years for the drives, even in those corrosive environments. So really great technology. And by the way, last takeaway from this slide is those global certifications. So we do have global certifications for all of these drives, just like the 755 of today. We're going to be able to cover the same reach, if you will, in all the regions of the world with those global certifications. So I had mentioned the Total Force technology and the Total Force platform. One thing I wanted to do here, Shawn, is just give a real quick overview of the entire portfolio of our 750 series products. So over on the left-hand side, you can see our 753 as well as 755 drives. Those are still part of this portfolio, critically important to all of our customers as they've been using these drives for a number of years. Now, as we make enhancements and add the Total Force technology, you can see in this kind of salmon-colored look here on the screen, now we introduce the Total Force technology both in our active front-end drives, so that's the PowerFlex 755 TL, as well as the TR, L being low harmonic, the R being a regenerative and low harmonic drive, as well as our TM drives. The TM drives designed specifically for those common bus applications, those coordinated drive systems. And the last piece, which we were just covering here, was the 755 TS, which is really an extension of the functionality of our 755 drives into those lower horsepower wall mount drives. So this is Total Force technology and the entire portfolio of 750 series products. Yeah, Shawn.
No, that slide does a great job of explaining it. Are you going to touch on UL 61800-5-1? I noticed that's not listed with the PowerFlex 753 and 755, and I'm not familiar with that. I didn't know if you want to touch on that now or if you had a slide on it.
No, I don't have a slide on it, Shawn, but it's a great time to talk about it. So UL 61800-5-1 is the new standard from UL for certification of variable frequency drives. So the previous certification from a UL perspective for variable frequency drives was UL 508C. And 508C has been around for a very long time. In fact, the 753 and 755 drives are certified to that 508C specification. But like all things, right, we evolve over time, and the standards community continues to evolve as well. And in fact, UL has evolved into their new standard, going away from 508C and now into this 61800-5-1, being their new harmonized specification for variable frequency drives. Now, the question always gets asked, why 61800-5-1? Boy, that 508C was a whole lot easier to say. Well, part of the reason for that is what they did was they harmonized to the international specification as well. So there's an IEC equivalent to this, which is also 61800-5-1. So that's where that comes from.
Thank you.
You bet. So Shawn, I talked a little bit about the Total Force technology. I want to go into a deep dive of what Total Force technology means to us. And again, going back to those three key tenets, right? It's going to be flexible, high performance control, real-time operational intelligence, and automated commissioning and optimization with our adaptive control technology. Of course, that all sounds really good, but what in the world does that mean? So the idea here is just kind of peel back, if you will, the facade of each one of these and talk specifically about what those technologies bring to the table for our customers. So the first one, we'll hit this one head on: flexible high performance motor control. What in the world is that? Well, first off, in order to be high performance, we have to have performance. So the idea here is performance is measured in a number of different ways with variable frequency drives, but most commonly high bandwidth. So the amount of bandwidth that you have in your control is critically important to driving that performance. So high bandwidth is absolutely something that was at the, if you will, at the forefront of everything that we were doing with this new platform. Torque accuracy. Now, as we get into applications, web applications, where we're doing tensioning, torque accuracy becomes extremely important in closed loop control. So adding torque accuracy, right, or reducing torque error becomes critically important to driving performance, as well as disturbance rejection and velocity tracking. Again, as the motor is operating, we need to make sure that the information coming into the drive is accurate, that we can reject certain disturbances to make sure that it's not impacting the overall performance of our control loops. And that's one of the things, but more importantly, is motor agnostic control. So this is really the ability for our drives control to be able to operate a multitude of different types of motors, to be able to control those motors well. Things like induction, which have been around for a very long time, right? Induction motors, but also some of the newer motor types like permanent magnet motors, both IPM and SPM, synchronous reluctance motors, as we start to reduce the demand on some of those rare earth magnets, as well as non-motor loads. So non-motor loads being some of the variable voltage output applications, things like magnetic stirrers, for instance, being able to control all of those effectively with a single motor control mode or motor control type, which is our total force technology. This is really important because we're not asking our customers to go change out their controls to be able to operate and control various types of motors. Instead, we've added that flexibility of motor control right into the core platform for total force. And then, in addition to that, right, is around the control modes. Flux vector being first and foremost, so that's the field-oriented control. Sensorless vector, as well as volts per hertz or scalar modes. Even economizers and the adjustable voltage, again, for non-motor loads, become critically important. And having the flexibility in those control modes, again, drives the performance, but also the flexibility in that motor control. The whole reason for that is to get after each and every one of those applications in the various industries that we have listed down at the bottom. Anything from auto and tire all the way through marine, even your life sciences, right? As we talk about, the need for pharmaceutical drugs around the world. PowerFlex helps drive that flexibility in its capability of motor control to go serve those application needs. So that's really, in a nutshell, high performance motor control for us. And again, the idea here is to be much better than our outgoing 755 drives in terms of motor control technology, but also to benchmark ourselves against previous products or even competitive products to drive that high performance motor control. And that's what we've done with this platform.
Now, I noticed one of the things you had on this slide is device logics. I haven't seen that in a while. Is that something that's being brought to life in the TS?
It is. So today we actually have device logics in the 750 series products. So even 753, 755 have device logics. But what we've done here, Shawn, again, with the additional horsepower under the hood with total force technology, we've allowed ourselves the ability to go in and make some enhancements to the device logics that are built in. So now we're going to be able to do nearly 4 times the number of function blocks, but also be able to transact each one of those function blocks at a rate of about 5 milliseconds as a scan rate. And that's internal to the drive. So very fast, if you will, onboard control capability, especially for customers that are looking for standalone, just single drive with a little bit of, if you will, control on board.
Excellent.
Mm-hmm. So that's high performance motor control. The next thing I want to talk about is something that's near and dear to my heart, which is real-time operational intelligence. And to understand real-time operational intelligence, it's really the whole purpose of this technology is to go and take the real-time data that you have as the drive is running. So it's capturing its own information. It's starting to become, if you will, self-aware of its environment. It's also becoming self-aware of the way that you're operating the drive. How often am I going through a thermal cycle? How often am I seeing these higher temperature levels, right? Is it cyclic throughout the day? As we see temperatures rise and fall, especially for me, as I live in the Midwest, right? Today it's extremely cold. Middle of summer, it's very hot, right? We can reach 100 degrees Fahrenheit. So the idea here is for the drive to be able to recognize that, understand it, and of course, turning that into important information for the user. And really that's around contextualization of that information, as well as the analytics or the knowledge that comes along with it. And of course, the output for us, the most critical part of this entire process, is making sure that we reduce downtime, unexpected downtime, as a result of a critical component needing service inside of the drive. So real-time operational intelligence is around gathering that real-time data, understanding it, and then driving an outcome to our customer that says, hey, it's probably time to go maintain this component inside the drive because you've got X percentage of life remaining or X number of hours remaining before we believe that component is end of life. Shawn, the easiest way to compare this to something in real life for many of our customers, and this resonates really well. Think about the way that you maintain your vehicle, right? Most folks have a car, they drive it to and from work. Most of them are not thinking about, hey, when's the next time I need to get an oil change? And historically, if you look at older model vehicles, we did that, right? We did this concept of kind of a timer-based maintenance approach, which was the odometer on our vehicle. So every 3,000 miles, without fail, right, it was time to go take it to the lube shop and they change the oil and check a couple other things, change the oil filter, and away you'd go. Well, now fast forward to modern day vehicles, and instead of waiting until 3,000 miles, instead what we do is we wait for the car to tell us it's time to go service our oil. And we do this via a very simple indication on the dash that says X percent remaining oil life, go service soon. And what the vehicle is doing is exactly what we're doing inside of our drives, is it's taking into consideration the way that you drive. If you're a lead foot, if you like to have your vehicle idle a lot, right? Especially, again, I'm in the Midwest, it's pretty cold here, right? You remote start your vehicle. Maybe you're in a lot of stop and go traffic. Takes that into consideration and says, hey, this is the amount of oil life that you have left. The same concept holds true here with our predictive maintenance evolution. So we currently in the 755 have a timer-based or an odometer-based solution. And it works extremely well. Don't get me wrong. This really helps drive unexpected downtime by making sure that folks are continuously in and effectively changing out those components before they get to the end of their life. The reality is, in today's world, taking in that real-time data, we can start to predict what that life expectancy is going to be. And the outcome that we drive from being able to predict is now, instead of our customer or end user going in and changing that fan because it's no longer turning, or maybe changing that fan early and spending more time on maintenance and more cost on maintenance. Instead, what they're doing is they're taking the real-time analytics, this predictive maintenance information, and from that, they're driving outcomes based on the data that's being collected by the drive. And that becomes incredibly powerful, especially for customers that have planned downtime inside of their facility to go do PM events. This helps them because they can go in, read the data from the drive. Okay, that fan's got 80% remaining life. We don't need to go change that fan during this PM interval. We can wait till the next PM interval or the one after that. So that information, again, knowledge is very powerful. And that's what our predictive maintenance capability is all about.
As you were going through that example, I can so appreciate that. When I got my last car, a 2011 Charger, it had the predictive oil sensor where it was not every 3,000 miles. If I did about 4 to 8 hours worth of highway driving a day, and I could get 5,000-6,000 miles out of but if I was doing a lot of city, it would come down. It would be like 3,000, 4,000 miles. And it was appreciative because you knew that you weren't changing it or just, throwing away, good product for no reason. I think I can definitely see this being so appreciated. I know a lot of the listeners out there, they're used to using popcorn drives where if it fails, you just replace it. But on mission critical systems, on larger systems, there's just a whole number of components inside that drive that you're going to service over time, over the life of the drive. And that's, just like you don't use the same tires on your car that you did when you bought it 20 years ago. Same thing with a major capital investment on a large VFD. So I definitely see in this being next gen and something that's going to make a lot of people happy and really give them peace of mind too at the same time.
Yeah, certainly, Shawn. And real life example of that, right, is the automotive piece. But now as we shift and we talk about it in the automation world, right, in the industry that we play in, it is not uncommon for me to still go into customers and hear that they have a technician, right, an engineer that simply walks around the plant and checks all the door fans, right, to see if they're still spinning or not. For some folks, that's an appropriate preventative measure, right? Is for somebody to walk around before or during a shift change and make sure all the fans are operating. The reality is that works extremely well. It works really well for fans and blowers because you can notice that component needs to be replaced. But Shawn, the real question is, what about something like an IGBT? What about something like a bus cap, right? Two critical components to the functionality, right? The operation of a variable frequency drive. And for those of you that don't know what IGBTs are, completely understandable. This is the power device. This is that switching device, the silicon device that does a lot of the work inside of the drive. And without an IGBT, or if that IGBT gets to the end of its life, well, unfortunately, that means that your process stops because we can no longer control your motor. So IGBTs as well as bus capacitors are critically important to the application of the way that you use your VFDs. So how do we go and maintain those? Well, I can't go do a visual inspection because this is what an IGBT looks like. I can't really look under the hood of that, right? So instead, what we've developed is our own predictive maintenance models to understand when that component is going to be near the end of its life. And the way that we do that is through something called a physics of failure reliability model. And a great example of that is, something as simple as temperature changes inside of the device that negatively impact the bond wires inside of the drive or inside of the IGBT. And these are bond wires here on the right-hand side. So over time, you get some thermal fatigue, those break. Unfortunately, that's a wear out mechanism of this device. Okay, so how do we create a model around it? Just like the oil model that you have in your vehicle for your engine oil. Well, what we do is we take these as key real-time inputs, things like switching frequency modulation and vehicle for your engine oil. Well, what we do is we take these as key real-time inputs, things like switching frequency modulation and to our model. And by the way, this model has been developed over 10 years of research and development from our organization, from our drives organization. And from that, we can understand what the cumulative damage is. We can understand the physics of failure, the physical reason that the device fails, and understand the cumulative damage associated to it. But we're going to do all of that in the background, just like your vehicle, right? It's doing all of that calculation in the background. Instead, what it's going to give you is percent life consumed in the remaining life hours of that particular device. Critically important, a key outcome for our customers is to be able to understand when these large capital assets, as you mentioned earlier, Shawn, when those need to be serviced, to make sure that we have that reliability that our customers expect from PowerFlex drives. So after real-time operational intelligence is the last one, which is automated commissioning and optimization using our adaptive control suite. So in order to frame this one up, Shawn, first we have to talk about the customer problem. And really the customer problem here is no longer talking about the drive. We talked about that in real-time operational intelligence. Instead, what I want to talk about now is the machine, because every motor should be connected to some type of machine. Now, some of them are very simple, things like fans and pumps, but some of them are more complex. And in fact, you can see a great example of a paper application here on the right-hand side. So a couple of things that are changing, right? The mechanics of the system are always changing. So we have things like compliance. We also have backlash, couplings, belts, so on and so forth. But we can also have some other things like vibration, right? Some of the flexible linkages, right, that start to shake or wear loose over time. And really summarize that as machine wear, right? All of that creates resonances inside of the system. Now, some of those we can hear. And in fact, some of your maintenance folks that may be inside your facility, they can hear this, right? They can hear that vibration and go, oh, hang on, it's time to go grease that bearing, or it's time to go replace that belt. Well, that's fantastic. But in other instances, you may not be able to hear that because the application is too loud. So what do we do to go and protect against that? What do we do to go protect against machine wear as well as heating that occurs, right? And that's exponential over time. And more importantly, how do we drive additional capability and efficiency in terms of power consumption and improving overall performance of your machine? Those are kind of the key outcomes. And first place it starts, of course, is inertia. Unfortunately, the inertia in the system, and you can see this is a pretty large inertial load, right? A big reel of paper, that amplifies our problems, and it makes it more difficult and more dynamic for us to adjust. On top of that, all the machines are different. So the same machine built twice and run in parallel, both machines will act differently. It's just the nature of mechanical parts. Oftentimes you're using auto-tune. Auto-tune is a great technology for the drive to understand the motor. Unfortunately, it's not a great technology in the drive understanding the application. So additional manual tuning is needed to go and make those small but important changes to drive out the best performance. But of course, that takes time. It takes an expert, right? We talk about the aging workforce and those folks that have 30, 40 years of experience doing this. Well, what if I've got somebody with less than that experience? Well, now it's going to take them even more time, or I have to pay for one of those experts to come in. So the whole idea is we need an automatic tuning capability. And with the Total Force technology, we've now implemented that in the automated commissioning and optimization. So what that looks like, this is a great example of just a simple steel process. As we talk about the actual load, we can see the load in the system. We see some mechanical changes that may create some additional disturbances inside of the system. So what are we going to do? What are the technologies that we employ inside of Total Force technology to go fix or adjust those various changes to get us back to a normal operating condition? And the way that we do that is with something called adaptive control. So adaptive control is made up of 4 important members. First of all, load observer. Second is adaptive tuning. Also reference notch filters in the way of things like anti-sway. And then lastly, smooth move references. So all of this sounds really fancy and really good. What I'm going to do is boil all 4 of these down for you in the simplest of terms. And rather than walking through the actual tuning loops that you can see here, instead what I'm going to do is keep this at a high level to explain it to the entire audience. So first and foremost is load observer. So what load observer does is it goes and finds all of those various disturbances or frequencies impacted by something that's called in-band. Okay, so this is inside your control operating range. Oftentimes this is 100 hertz or less for nearly most applications. But the idea here is that load observer goes and understands the differences of inertia mismatch, the things like couplings or gear lash or compliance right in that coupling, and automatically finds those and adapts them out, right, and gets rid of them. And the way that we do that, Shawn, very simply is we make load observer cancel out all of the load torque. So we find out how much torque is needed for the application, and then we minus out the torque that's needed just to be able to, if you will, operate the shaft. So load observer is simply put taking the understanding of an unloaded motor and applying that in all applications, in all use cases. So when we act as if the motor is unloaded, the benefit that we get there is we can have the fastest and highest bandwidth in terms of our feedback loops. The benefit, of course, is that we create better stability inside of the control by using this technology. But simply put, think of all of those different disturbances that could be in the system, inertia mismatches or inertia changes over time, and Load Observer is designed to cancel those out. Understand them, make real-time adjustments, and cancel them out. With adaptive tuning, now we think about the frequencies that are outside the band. So Load Observer is finding those frequencies that are in band. What about the things that are well outside? And what we've learned over time is the hotter we tune our drive, the better performance we get out of the drive by using Load Observer technology, the more stress it's going to put on your mechanical system. Well, hold on, we don't want to put additional stress on the mechanical system. Well, the reality is what we're doing is we're creating new resonant points, or finding those resonant points, I should say, inside of the mechanical system as a result of it being optimized in terms of the overall performance. So with adaptive tuning, now we find all those frequencies that are outside of band, those higher frequencies that are creating those resonances in the system, and we tune those out. And the way that we do that is actually with 4 high-frequency tracking notch filters. So those tracking notch filters go and find the 4 highest frequencies, the highest resonances, automatically set themselves to it. And the easiest way to understand this is think noise canceling headphones. Same concept. With that high frequency noise, we want to cancel that out. And that's what we're doing inside of the drive control. And that's exactly what adaptive tuning can do for you. Now, these two technologies working together, both a Load Observer as well as adaptive tuning, provide for a much better drive tuning experience. It also provides for higher performance, which the customers are looking for to make sure that we can drive as many widgets out per hour, right, on our particular manufacturing line. And then lastly, as we talk about load vibration, right, we want to make sure that in this case, what we're trying to do is keep the load under control. And there's something pretty unique about this. Think about it as a spring, right, in the application. We can model this in math, but think about it as a pendulum, as probably the simplest form. As I move the pendulum, or I'm moving my crane from point A to point B, I create an acceleration and therefore a disturbance. I create a vibration. Now, in a pendulum application, the vibration is actually a period, right, of the swing in this case. And so we can see that. And load vibration is, by the way, something visual. You can actually see it. Typically, it's under 10 hertz, that resonance. And in fact, a lot of the time, you can actually use a stopwatch and go find that particular frequency. Well, by using some of our new notch filters and our command notch filters specifically, not tracking notch filters, we're able to go find those resonances and correct them. And this is why we've implemented a new technology called anti-sway, open loop anti-sway performance, as well as anti-slosh. So anti-slosh in your typical food and beverage applications, where you're starting and stopping at each one of the stations. The idea here is we can account for that load vibration and automatically cancel it out as long as we know what that resonant frequency is. So again, neat technologies, adaptive control, performance, it drives performance in your overall motor control. But in addition, as we start to see the mechanical system wear, as we start to see our system adjust, right, to bearings that become a little bit more loose, couplings that become sloppy, or belts that start to stretch, these technologies will help keep the system under control and, of course, driving that critical outcome for our customers, reducing unplanned downtime. And last but not least is just kind of my summary slide here around the PowerFlex 750 series portfolio. Great technologies with total force technology with Total Force as our technology for motor control. And again, that can be found in the new 755 TS coming out here soon, as well as our existing products of the 755 TL, TR, and the 755 TM. So Shawn, that's what I had for you today. Any additional questions in closing?
No, that was really great. I'm very interested. I'll have to keep track on the progress. And is there any place you think our viewers or an audience who want to learn more about this should go to find out more? Do you guys have like a spot on the ab.com website, or is there a specific piece of literature you'd recommend they grab?
Yeah, in fact, we do have a number of pieces of literature that are out there. All of them, by the way, that you can find on ab.com. But most of them around our drives technology in general. So we do have a drives landing page on ab.com. And in there, Shawn, there's some great selection guides as well as technology guides around our Total Force technology.
And just for the audio audience, if you see 755T, that's going to be one of the products with these new Total Force technology features in it. So we're specifically talking the 755TS, but that T at the end, TS, TL, TR, TM, those are the in the section of the slide that if I know you can't see it, but those are the products that are all kind of in that same grouping. So throw that out there.
And Shawn, one last point to make here in closing. T stands for Total Force.
Sure.
So you'll see all of our new drives as we bring out the Total Force technology. You'll see the T in the name, and in fact, we've stretched this into our medium voltage space as well.
Oh, all right.
For those of you that are in the medium voltage variable frequency applications, we do have our new PowerFlex 6000T, which features the same Total Force technology that I talked about here today in the exact same control platform. So the user experience is the same, both between low voltage as well as high voltage. And if you think about that, scaling that from 1 to 6,000 horsepower and even into medium voltage makes this very user-friendly for our OEMs, our SIs, and our end users alike.
That's great. Now, just to make sure we cover this completely, are there any legacy products that may have 755T in them that would not be part of this family?
So great question. Right now we're going through that control evolution. So the products that we've talked about today are the products that have the Total Force technology on them.
Okay, so yeah, keep in mind, folks, if you're listening, TS, TL, TR, TM. And Adam, I just want to thank you for coming on. That was a great presentation. I feel like I've really got up to speed on what you're working on and what's coming. And really just thank you for taking time out of your busy schedule to come on the show and bring us up to speed.
You bet, Shawn. It's been a pleasure. Thanks a lot.
Well, I hope you enjoyed that episode. I want to thank Adam for taking time out of his busy schedule to come on the show. With that said, if you're watching the video edition of this episode, please give us a like and a sub. And if you're listening to the audio-only edition, please consider giving us a 5-star review because it helps us find a wider audience as well as find new vendors to come on the show. And thank you to the folks who have already done so. I really appreciate it. Now, if you want to keep track of me, follow me, and maybe even support the show, you can do so over at automation.locals.com. And of course, you'll find all my training courses over at theautomationschool.com. With that said, I want to wish you a very happy, safe, and healthy week. And until next time, my friends, peace.